Okay, we're back with another video, and you can see there's a radio on the bench here. We're not actually going to be doing anything with that radio other than using it for an RF source. What this video is mainly on, is we'll be looking at, it's not so much just the meter, but it's a probe that's used with it. Right here, it's an adapter. This is a old antique vacuum tube voltmeter. It's a ME-26D/U, which was made by Sentinel Electronics, but it's basically just a HP-410 series multimeter. Okay, so very good meters, built like a tank, and of course the military versions are even more robustly built. But the biggest advantage of this series of meter was it can accurately measure AC voltage up to 700 megahertz and is usable well past 1 gigahertz. Something you just don't see in other multimeters. And one of the things that made that possible was this rather unique probe, AC probe, that comes with it, and it's permanently attached to and this is a double shielded coax cable. But this probe actually has a very small iMac vacuum tube built inside. And the meter's been on for a while. You see the red light there at the bottom, and it's actually warm. And that's one of the reasons this meter can read frequencies so high. But one of the other neat things you could do with this meter was you unscrew this end. You see these two little ears on the side? Well, that's where this line, basically it's a line section, I guess you could consider it. It just installs on the end here. Like so. And now this one was, I'm not sure why it has one on either side. I've seen these in two styles, one with two adapters, or a connection on each side, and one with only the connection on one side. But it's basically an N connector, female and a male. And then on the inside, you can see there's just a little contact button on each side for the probe. And it's just a pass-through, goes from one side and out the other. But it now allows you to take direct voltage measurements of an RF frequency. And accurately, like I say, because this meter is accurate up to 700 megahertz, it allows you to take those voltage measurements accurately up to 700 megahertz, and you can still get meaningful. They won't be accurate anymore, but it will read well above 1 gigahertz, and so you could, theoretically, you could use this thing on measuring even like the 23 centimeter band. That starts off at 1.24 gigahertz and goes to 1.3 gigahertz. So, the readings wouldn't be accurate that high, but you'd still get needle deflection. So, if you were tuning something, you'd still have a reasonable measurement that you could use. But like I say, being accurate to 700 megahertz that's really handy, especially being able to do it with something that old. So I'll stop the video here and we'll get it restarted in a second. I'll have everything hooked up so you can actually see this probe adapter with the probe and the meter in use. And like I say, we're just using this for an RF source. Okay, so we're back with the probe now connected. Coax cable goes from the radio, and I don't like to use adapters because they can, every time you add an adapter, that can take a little bit off your measurement. But so we have standard UHF connector going in the back, goes to N connector on the other end of this cable, which hooks up to the adapter, and then N connector coming out of the other side of the adapter. That goes straight into the communications test set. I'm just using that for a dummy load, because this is not a load, it's just a line section for measurement, so you need a dummy load attached to the other side, so that's what the communication test set's being used for. And of course the probe adapter is installed on the end of the AC vacuum tube probe, and I have the meter set to the 30 volt scale, so I can catch the radio and meter in the background there. So you can see that allows you to take direct AC voltage measurements. And as I talk into the microphone, you can see you're getting your swing because your peak-to-peak voltage is going to go up as you're modulating, because this CB radio is AM, so as I modulate the carrier, you can see the voltage go up. So it's basically you've turned your multimeter into a power meter. You know, you're getting voltage measurements, and you could take your voltage measurements off of this meter, then be simple math to convert your voltage measurements off of the meter and convert that into watts or dB or whatever measurement you feel like using. But I just thought I'd do a quickie video to show this probe adapter, and I know Buddy over at the YouTube fame. He's starting to get famous now. He just recently went over 600 subscribers, and actually I think last night when I watched one of his videos, he's up already to like 690, I think so. His YouTube videos are getting famous. He's quickly picking up subscribers. So, but he's in the process of rebuilding a HP-410A multimeter, which basically the same. This meter here is based off of the 410B. So this, where his meter has the tube that's inside of this probe here, in his meter, he has another one built inside of the meter itself. It's actually a pair of diode tubes. This meter only has one. That's the tube in the probe. There's a bunch of other vacuum tubes, of course, in the meter, but there's only one of those small iMac tubes, and thank God, because those things go for $50 plus nowadays. But it's still basically the same meter. Now, the only thing is, and I'll say this mainly for you, buddy, I'm not 100% sure if this probe adapter will work with the probe that you have. I know this will work with the 410B and the 410C, but your probe is a little bit different. Where this one, get it unhooked here, where yours, for starters, doesn't have this rubber insulator, keep your hand from getting hot, but yours has a locking ring on the back you unscrew, and then you pull it out to get to the vacuum tube. This one, you just take these two screws out, which are the ears that lock in on this. You take off those two screws. The cap comes off, and it has a wire. And where your vacuum tube has a little, it's spring loaded. The vacuum tube that's in this one is just a tip sticking up, and then there's a wire that goes to that. It just snaps on. So the probe's a little bit different. But without going to your video right now to see, I'm not sure if one of these would work on it or not. It might, and I didn't even think about that before I did this video to go pull, because I've got some 410As shoved away somewhere. I mainly use these meters because I have a bunch of these. I really like the military ones. Just, like I say, build a little bit more sturdy. And these, one of the main things is if you ever have to calibrate these, there's no disassembly involved. Unlike the other ones, they're a little bit more complicated to get to. This one, you just loosen 4 quarter-turn screws on the back. The back panel pops off, and every calibration adjustment's very easy to get to right at the top, and basically right behind this meter movement, facing backward. All the calibration adjustments are right there. So you don't have to do any disassembly at all of this meter to calibrate it. And I have a bunch of them. I've got, I think I've got 2 more of those still in their vacuum bags. I mean, they were rebuilt back in, I think one was in the 70s, another one was rebuilt by the military in the 1980s, but they're still sealed in their vacuum bags. I'm just a really big fan of those. I like them. If you work on radios, and that's one of the reasons I use this communication test set. Digital meters are nice, but when you're trying to peak something in a radio circuit, it's almost impossible to do with a digital display. Analog meters are great, and this makes it very easy. Of course, when you're working on vacuum tube equipment, they're going to tell you to take a lot of measurements. When you're doing a lot of your adjustments inside of a vacuum tube transceiver, they're going to tell you to use your VTVM. And usually, most books back in the day would have told you to use a HP-410 series meter, because that was the lab meter of the day that most high-end repair benches would have had. And like I say, this is basically the same thing. It's just better because it's the militarized version. So unlike the HP-410s that would have had the electrolytic capacitors, like the one you saw if you watched Buddy's video he posted either last night or night before, has the electrolytic capacitor. It's a paper cap. The capacitors in this thing are hermetically sealed. The capacitors in this are the original caps from back in the day when this thing was made in probably the, if I had to guess, early 50s, really late 40s, early 50s. So they're still original. You know, same thing with that HP power supply right there. I also have its big brother, the HP-410. The electrolytic capacitors in that thing are still, believe it or not, they're still original. I disconnected them and tested them for leakage, and they're still fine. Absolutely perfect, you know, after all these decades. But that's one of the advantages of the military meters. They use really high. I mean, don't get me wrong, the 410s were good quality, but these things were, you know, built for, well, the military use. Take it, you know, bouncing around in the backs of trucks, and you know, you could probably almost literally run over that meter. But like I say, this was a quick video on this probe, how it works and what you can use it for, and how easy it is to use. Like I say, just unscrew your tip, couple it to the probe adapter, hook up your antenna connector and a dummy load, and you can take direct voltage measurements off of an RF source accurately up to 700 megahertz, and you know, like I say, usable readings well in excess of 1 gigahertz. So there you go, the HP-455A. They call it the Probe X connector.